Alrighty, howdy there guys. ThatGuyMontie here for another video. Just kind of doing a startup video, just to kind of introduce everything. I'm an ag student, graduate student at Texas State, go Bobcats, and just wanted to go kind of share some of the stuff I've been looking at, some of the research I've been going through. Just because there's a lot of questions out there on the internet, and when we tried to find answers, it really just kind of took a lot of time. So trying to consolidate some of those answers that people look for, both just for the general online community and for our school. So to start off with, this is just a hydroponic system that I've been running for about a year now. I planted it 290 days ago. Originally, it had a bunch of different stuff. This is about the third or fourth crop that's been through here. The first one was mainly kale. After that, tomatoes. And then I've got a second one in our kitchen that now has those tomatoes. And this one obviously went to lettuce on one side and herbs on the other. So we have a couple different varieties of lettuces here. Paris Island, Red Sails, Marvel of the Four Seasons, um, Black Seeded Simpson, Rogue d'Or, if I'm saying that right. Most of these were all varieties that were sent by Arrow Garden. That's the company that makes this. They come with a salad bar kit that has some tomatoes and lettuces. And this is the setup I got when I ordered my second one. It also comes with dill, chives, lemon balm, mint, tarragon, savory, thyme, parsley, cilantro. A pretty good mix. So you can kind of see a little of the difference between how different herbs do in it and how lettuces do in it. And just to kind of do a little tech demo, I do have a microscope set up here. This is my microscope that I purchased. And I also have an Amscope camera with it as well that is running to my MacBook Pro over here. Or I mean, sorry, my Surface Pro. MacBook Pro is my old laptop. And it's pretty cool. You can see as I adjust it, you can see it's actually just a slide of some of my own blood. I know that's kind of weird, but it's really the only thing I could find that I was definitely going to get an interesting look at immediately, if that makes sense. These are just a couple old slides I've made. I've had this microscope for about 4 months now. It's not too long, really just kind of getting into it, really got into it because of Elaine Ingham doing her just analysis of how to find a microscope was very, very helpful. Reading a lot of her compost teas, that's what my thesis is actually over, is compost teas and hydroponics. So I'm looking at kind of developing something I'm calling vermiponics, which is basically just running a deep water culture or recirculating system, even ebb and flow, strictly off of compost without adding any fertilizers, whether they're organic salts, whether they're inorganic salts. Regardless of where those are coming from, really just trying to pull out the raw nutrients in soil or in a compost. Um, I worked in a hydroponic greenhouse for a while. We used the nutrient fertilizers quite a bit. I've used some organic fertilizers at home personally when I grow stuff, just because of the organic craze, kind of. But there's a lot of science and chemistry behind why things are organic and why things are inorganic that a lot of people don't really go into. And a lot of that has to do with biological activity, and a lot of it is the terminology gets a little confusing talking about organic and inorganic. Plant available is another word that gets thrown in there. So just kind of going over some of those confusing concepts, going over some of my research that I'm conducting, and just going over some of the pitfalls that we found during our first couple trials. Hydroponics and farming in general is a very, very difficult field to get into, but once you do, it can reward you in so many different ways and really become a lifelong passion. And so that's something that we really just kind of want to cut down that energy involved in getting into it, because we are going to need many more farmers, and we're going to need them to start growing in unconventional methods. Um, so with that, I hope to see you guys in another future video where I will be going over dissolved oxygen. First of all, the blowing the myths out of the water, as I like to say, because there are a lot of myths with dissolved oxygen, and not always are you going to go with the more is better approach. A lot of people like to buy the really big, heavy duty aerators. I see pumps that can do 950 gallons per hour. And really, that's, in my opinion, that's just too much. In the next video, I'll talk about it a little bit more with some DO probes that we have. and go into different aerators, different numbers of air stones, different types of air stones, and the saturation limit of your dissolved oxygen, and kind of, what are you getting for your buck? Mainly, we're going to go over this topic because we kind of had an internal debate, I guess you could say, over which ones were going to be the best. And it really, really surprised us which ones came out as the leader of aeration, creating the highest dissolved oxygens. Were actually some of our smaller pumps with the smaller stones and fewer outlets. And really, the only mechanism behind that we could see is that the longer the air is in the water, the more time it has to dissolve in it. If you're just kind of blowing water or air straight through the top of water, it's just going to come out directly into the atmosphere. Whereas if you have a recirculating pump, or if you have something circulating it, creating micro bubbles, we like to call them, which almost act as coleoids that just continually float around in suspension, going up and down without making it to the surface to break. So that is how you're going to get the highest dissolved oxygen, not necessarily by pumping more air through less water. So I hope to see you in that upcoming video. And after that, we'll be going over some nutrient analysis using simple titrations that you can get at any pet store. API freshwater test kits are what we'll be using, and a pond water test kit. They're about $30. Very, very good water testing titration, especially if you're new to it. Finding probes are very, very expensive. They're very testy. They can be damaged within one season, and you're out money. Which is why I really prefer titrations. It's $30. If you lose all those chemicals, you're out $30 and not 1,000. On top of that, it's a really good way to train people to be mindful when they're taking data. Count out exactly 6 drops of this and exactly 10 drops of this. So it really gets people into that mind space of being very, very cautious and mindful when they're going through an experiment, so that they don't mess up. And I think that about wraps it up. I'm looking forward to seeing you later, guys. Oh, and I had an outro, which was... No way I'm going to remember it.